Hi everyone, today we're talking about the quadratic formula. It is yet another way that you can solve a quadratic equation, and it is, unlike the factorization method, always going to work, without a doubt. The downside, though, is that you have to memorize a formula. And we actually use completing the square method to derive or come up with this formula. And it works for the quadratic equations in the format ax squared plus bx plus c equals 0. So it doesn't matter if you have a non-1 coefficient in front of the x squared. So now I'm going to show you how we actually derive this formula. I won't test you on this. It's just interesting where it came from, but you won't have to do this on your own. As long as you memorize the formula at the end, you'll be fine. Okay? So again, we are figuring out the quadratic formula by using completing the square. And we just start off with our normal quadratic equation. Ax squared plus bx plus c equals 0. No numbers in there. We have a, b, and c in there instead. Okay? Now remember, in order to complete the square, we need a coefficient of 1 in front of the x squared. So we do need to get rid of that. We're going to divide everyone by a to get rid of that. Okay, so now a divided by a is 1x squared. Now we're left with b over ax. I'm just shifting it over so that I can treat it as if it's a coefficient. Plus c over a equals 0 divided by a is still 0. We know from completing the square that we don't like this constant, right? So we know we're going to get rid of it on the other side. X squared plus ba over x is what's left over on the left-hand side equals negative c over a. All right, so then now we're going to complete the square. And normally we would take the b value, divide that in half, and square it, right? Now our b value is b over a. B over a is our b value. We have to divide it by 2, okay? So that 2 is already on the bottom. So we're just going to place it on the bottom to join the a. All right, again, the 2 is in the denominator normally when we divide by 2. We already have a number on the denominator, or a term, which is a, which is fine. We'll just shift them or group them together. Okay, that'd be like normally if we had, I don't know, 5 divided by 2, right? It's the same as 5 over 1, and then you put that 2 on the bottom. It just stays on the bottom. Every number has a denominator of 1. We just don't think about it. So it's basically just joining that denominator of a. Okay, so now we have this to help us with completing the square. So I'm going to shift to a different color. We are going to add this term to both sides. Add b over 2a squared to the right-hand side, as well as the left-hand side, because we want to keep it balanced. Okay, so then now, back to my red, we have the ability to complete the square. X plus b over 2a times x plus b over 2a. Okay, because we're completing the square. Let's clean up this right-hand side. This becomes negative c over a plus, this is b times b because it's b squared. This is 2a times 2a. 2a times 2a, because the bottom is squared as well, is 4a, 4a squared. Okay, so this becomes b squared over 4a squared. All right, these are being added together. So in order for them to be added together, they need to have common denominator. Okay, so let me use a different color here. Their common denominator would be 4a squared. So the second fraction is already there. This first fraction needs to be multiplied by another 4a in order to get to 4a squared, top and bottom. Okay. Now let's go ahead and we're going to change that top, or the left-hand side, to x plus b over 2a squared, because there's two of them. So we're just getting ready to set up our problem. And on this side, we have a common denominator of 4a squared now. They're being added together, so this is negative 4ac, because these are multiplied, plus b squared. Okay. Now we can set up our equation where we have a square on the left-hand side. So in order to get rid of that square, we need to square root it. I know this looks super messy right now, but trust me, it'll work out. These two cancel, okay? And then I'm actually going to give myself some more room up here so that we can finish the rest of the problem because I'm running out of room. Okay, so I end up with x plus b over 2a equals the square root of negative 4ac plus b squared over 4a squared. Okay. Let me then erase the rest of this so I have even more room. And then I do see, as I'm erasing, I'm noticing my denominator right here. If it's being square rooted, that actually can be square rooted, right? So I have this copied back over equals the top. I'm just going to leave that mess, minus 4ac plus b squared. Okay, over 4 can be square rooted to 2, and then a squared can be square rooted to a, right? Because these two are basically both square rooted, right? I have the top square rooted, and then I also have the bottom square rooted. So I'm basically keeping the top square rooted, but the bottom I can simplify. 4a squared is the same, square root of 4a squared is the same as 2a. Square root of 4 is 2, square root of a squared is just a. Okay, so I can kind of simplify that bottom in that way. And I actually like that because then I know over here, I'm going to have to subtract b over 2a from both sides. So that is going to give me common denominators, and I can, boom, put these fractions together because they have the same common denominator. So this becomes x all alone on one side equals, let me move this to the front. I don't like my regular b kind of tagging along to the back of that square root. So I'm going to put that to the front, plus, let me put my b squared to the front, minus 4ac over, they both share 2a, so boom, they both share 2a. I can smush them together. This right here is the quadratic formula. Again, you don't have to know off the top of your head how we get there, but we basically get there. You do have to know that we got it using the completing the square method. Okay? If you want a more condensed version of what we just did, there it is. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Why were we solving for x? Because that's what we always solve for, right? So we needed to basically take x out and solve for x.
Now this part of the quadratic formula has a special name, and it's called the discriminant. And it's special because it actually tells us a lot about how this graph is going to behave. So since it's a value inside a square root, there can be three possible values. First, you could have a positive number inside the square root sign. And then as we know, you'll get either a positive or negative answer. So at the end, you will have two answers, right? Because you set it equal to either a positive or a negative. The second situation that you can have is you could do all the math inside the square root and you can get a discriminant value equal to 0. And in that case, you would then take the square root of 0, which would be nothing. So then you would end up with no positive or negative, and you would end up with just one answer. And we'll go over problems like that later. And then the third situation that could happen is you could end up with a negative value inside the discriminant, or as your discriminant, but inside the square root. And as you know, taking the square root of a negative value, like -4, for instance, is impossible. So if you have a negative value for your discriminant inside the square root, it would be impossible. So then you would actually end up with no real answers. It would be impossible. Okay, so these are all the possible types of discriminant values and their corresponding amount of solutions. Okay, so again, if you have a positive value, then you end up with two solutions because you can either have a positive or negative answer. 0 discriminant value would mean you would end up taking the square root of 0, which would end up being 0, and you would have only one solution. And then you would have a negative answer inside the square root, which is impossible, so that would lead the entire problem to be impossible, and you would have 0 solutions. Okay, so that is the discriminant. Super important.
Okay, so let's take a look at how we can actually use the quadratic formula to solve problems. So we're going to look at example 8 from the book. Okay, solve the equation 3x squared minus 5x minus 1 equals 0 using the quadratic formula, giving your answers rounded to 3 significant figures. All right, so we have the quadratic formula over here. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay. You notice that this formula has b's and a's and c's. So that's what you're going to pluck out from your equation. A value equals 3. The b value here equals -5. And the c value equals -1. So you're just going to plug that into your equation. Okay? So we have -b. My b is already -5. So -b would be +5. Plus or minus, very important, right? Because sometimes we have two different answers. B squared, my b is -5, so it's going to be squared later, minus 4 times my a value, which is 3, times my c value, which is -1. We'll deal with that stuff later. All over 2 times a. My a value is 3. And then I just have to solve this and I get my two answers. So again, quadratic is easy in a way that you don't have to do much thinking, but the hardest would be to remember that formula. And we have a bunch of different ways that you can remember. All right, 5 plus or minus square root of -5 times -5 is 25, minus, all right, let me do some math on the side, -4 times 3 times -1. Well, this would end up being positive because negative times negative is positive. 4 times 3 times 1 is 12. So it becomes plus 12. Okay, and then on the bottom, we have 2 times 3, which is 6. Okay, simplify this further. 5 plus or minus square root of, this is 37 over 6. You can keep this as an answer. However, this problem says you got to give your answer rounded to 3 significant figures. All right, so I'm going to have 2 different answers. The first using the plus and the second using the minus. So 5 plus square root of 37, take that answer, divide by 6 will be my first answer. 5 minus the square root of 37, that answer, divide by 6 will be my second answer. Rounded to 3 significant figures. So for the first one, square root of 37 is this. Add 5. Take that answer, divide by 6. So I get 1.85 because a 7 will round it up to a 5. 3 significant figures. So 1, 8, and 5 are your 3 significant figures. 1.85. That's my first one. Then I have 5 minus the square root of 37. All right, square root of 37 again is this, 6.08 blah, blah, blah. 5 minus, I'm going to do a little trick in my calculator that I love doing. If it's 5 minus this number, it's going to be the difference but negative, right? So instead of rearranging everything in my calculator, I'm going to take the square root of 37, subtract 5, and then I'm going to take the negative answer of that. Okay? And then I'm going to divide it by 6 to get my answer. So my answer would be negative 0.180. This 0 counts as a significant figure because it's a place value to show that this didn't round. So the answer would be negative 0.180. Negative 0.180. Yes, we do have to write that 0 because it's significant. It's showing that it wasn't rounded. Okay. Let's move on to number 9 in our book. Oh boy. Solve this equation using the quadratic formula. We are going to have to multiply this out and unravel it before we use our quadratic formula. Go ahead and pause the video and try it on your own first. Okay, let's do this. So 2x plus 3 times 2x plus 9. 2x plus 3, 2x plus 9. Let me use my Punnett square. 2x times 2x is 4x squared. 3 times 2x is 6x. 2x times 9 is 18x. 9 times 3 is 27. So the left-hand side will be 4x squared plus, these two are like terms, 6x plus 18x is 24x plus 27 equals, this is a distribution on the right-hand side, 4x plus 2. Now we can put all this stuff, move it from one side to the other. So let's move this 4x by subtracting it. And let's subtract this 2. Cancel, cancel. We want 0 on one side because we need everything in that quadratic format to use the quadratic formula. This becomes plus 20x, and this is plus 25. Okay. And then I can use my quadratic formula. My quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Let's change to a different color. So it is negative 20, because that's our b, plus or minus the square root, get rid of this, the square root of b squared, that's 20 squared, minus 4 times a, which is 4, times c, which is 25, all over 2 times a, which is 2 times 4. equals negative 20 plus or minus square root of 400 minus, let's see, 4 times 4 is 16. 16 times 25 is 400. Ooh, I like that. I like that a lot. All over 4 times 2 is 8. All right, so you probably noticed that 400 minus 400 is 0 at the end. So this all cancels. This ends up, let me maneuver over here. Since that square, everything inside that square root cancels, I end up with just negative 20. This plus or minus doesn't matter anymore because that was working with the square root. So I end up with this, negative 20 over 8. I can simplify that to negative 2.5 because 8 goes into 20 2 times with a remainder of 4. So you end up with 4 and 4/8. 4/8 is the same as a half. So I end up with the answer negative 2.5. Now, why does that happen? Well, it ended up being a problem that we probably didn't have to use quadratic formula for. It probably was, easily done without quadratic formula. Because quadratic formula does work for any problem. However, it's not always going to be the best choice. This ended up being a lot of work. You might actually be able to see what we could have done instead. Let me go ahead and erase this so that we have room to look at this. But take a look at this quadratic equation that we got at the end. We couldn't avoid, doing all this multiplication to get there. But once we got here in the blue, 4x squared plus 20x plus 25 equals 0, we actually didn't have to use the quadratic formula. This 4 is a perfect square. This 25 is a perfect square. So what we could have done if this problem forced us to use the quadratic formula. But if we had the choice, we could have just changed this into a special products problem. Because square root of 4 is 2, square root of 25 is 5. These are all pluses. So we could have gotten here really quickly and then taken 2x plus 5 equals 0 and solved that problem by subtracting 5 both sides to get 2x equals negative 5, divide by 2 both sides, and boom, getting to the answer really quickly. Okay, so a lot of people get angry and they think, oh, why did you have to teach me the easiest method at the end? It's not always the easiest, to be honest. It's the most versatile, but it does take some time. Okay, so 2 different ways to get to the correct answer here. However, the problem does tell you to use the quadratic formula. All right, last problem we're going to go over. Solve the equation 2x squared plus 7 equals 3x using the quadratic formula. Pause the video and try it out on your own first. Okay, using the quadratic formula, I do need to move this 3x to the opposite side because I want it to be in a particular format where there is a 0 on the right-hand side so that I can then use my A, B, and C. A, B, and C. Okay, using my formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now I just put in my numbers. Negative b. B is already negative 3, so it's going to be a positive 3. Plus or minus square root b squared, negative 3 squared. Notice how the negative is also inside the parentheses. Minus 4 times a, which is 2, times c, which is 7. Okay, and then that's going to be all over 2 times a, which is 2. Okay, now I can start simplifying stuff. Square root of, the square of -3, -3 times -3 is positive 9, minus 4 times 2 times 7. 4 times 2 is 8. 8 times 7 is 56. Right? Yeah. And our bottom is 4. Now, I don't know about you, but I'm looking at this stuff inside the square root and I'm thinking to myself, that doesn't work. 9 minus 56. 9 minus 56 is a negative answer, negative 47. I can't possibly square root that. Two numbers, two exact same numbers multiplied by each other, like 2 times 2, has to end up being positive. Even -2 times -2 ends up being positive. They would have to be mix matched. It would have to be a positive times a negative to equal a negative number, right? So this doesn't work. It doesn't make any sense. So the answer to this problem actually is that there's no real answers, okay? You'll see people saying that there's no real roots, okay? Or no real numbers will work there. And that's your answer. You get to stop right there. The problem has said, here's a freebie. It doesn't work anyways. Okay? Now, we will get to why, in future chapters, why it's called a root. Okay, when we start, not a future chapter, but a future lesson, why it's called a root. But just for now, just know there's no real roots, no real numbers work here. That doesn't mean that there's no answer, okay? It just means that there is no real root that works in this problem. And then once, like I said, once we get to graphing, then you will find out what we mean by that. Okay? Okay, and to further prove my point, if you were to put into your calculator -47 and you wanted to find the square root of it, you get this, not a number, okay? Doesn't work. Now, a real number doesn't work. You're probably thinking, what is a real number, right? Real numbers are just ones that work in our natural world. There's not a number that exists in our real life that would work. Once you get to a more difficult math class, you'll talk about now imaginary numbers, which then would work in this situation, but don't worry about it. I'm just telling you technically that it should say not a real number. We can find the square root of a negative number, but it's just beyond the scope of this course right now. So for problems like this, just put down there's no real roots, not a real number that works here.